welcome again, everyone, to our session called Materials Matter, about embodied emissions and materials. This is our manufacturers workshop. We have 4 workshops going on, so this is our second one. This is a partnership between the City of Toronto, the Atmospheric Fund, who's been funding 2 significant studies you'll hear about today. Mantle Developments, the University of Toronto, Passive Buildings Canada, and Builders for Climate Action. Next slide. And what we're going to be doing today is, so we've got you for almost 2 hours. We may be able to finish at 1:45. And really, we're going to be going through a series of presentations on the 2 major studies that are being undertaken right now. But the idea is to get some discussion going and input from you around challenges you face, work that you're doing around this in this space, advice that you have for us at the City of Toronto. As part of us completing the work that we're undertaking right now, excuse me. But we will have a break partway through at about 12:45 or 12:50. So we'll have a quick break then, and then we'll move into the discussion portion of the event. Next slide. And so just to introduce myself, my name is Lisa King. I'm with the City of Toronto City Planning Division. And I'm very involved in the development and operations of what we call the Toronto Green Standard, which I'll say a few words about. Those are our performance requirements for new construction. And with us today, we have Ryan Zizzo from Mantle Developments, who's the founder and CEO of that company. Kelly Alvarez-Doran, who's with the University of Toronto, working on something called the HAF Studio. And he's also an architect. And we have Chris Magwood, who's the director of Builders for Climate Action and works for the Rocky Mountain Institute. And he's working on the small building study, the Part 9 study that you'll hear about. Excuse me. Next slide, please. So the Toronto Green Standard, I mentioned it, it's been around since 2010, and it's in its 4th version this May, actually. And it has performance requirements that help to implement our environmental policies of the official plan within development applications. So it uses the development approvals process to secure different requirements that we have. So whether they're related to electric vehicles or energy performance in buildings or stormwater management, all those kind of things that we feel are important. We have 3 different standards. So for low-rise Part 9 buildings, the majority of our development, which is mid to high rise or non-residential type buildings, institutional, commercial. And then another standard for our own city-owned buildings. And that's the highest standard that we have. In May, for example, we're requiring our own city buildings to be net zero emissions in design and construction. And the TGS includes required and voluntary tiers. And I'll explain to you kind of something called our zero emissions building framework. If you go to the next slide, please, Ryan. So in 2017, 2018, we published something called our zero emissions building framework. The City of Vancouver has something similar called their zero emissions plan. And what it does is it sets out long-term targets for the energy efficiency and emissions performance of our large Part 3 buildings. And originally that framework was set out to 2030, where we would require very low emissions level buildings. And recently in December, our City Council bumped up that time frame. They advanced it. They asked us as part of our climate action plan to move our buildings requirements forward sooner in order to achieve what we call net zero 2040 for our citywide objectives on climate change. And so what that means is that instead of by 2030, by 2028, we will be requiring the highest levels of performance through our Toronto Green Standard. And so far, we've been very focused on operational emissions in buildings, but now with this new emerging issue that we're all going to be talking about today, a very important issue, we have to really look at the materials components, those upfront emissions as well, and work that into our standards and process. And what we've done with the Toronto Green Standard that's coming into effect shortly, actually this Sunday, version 4, is we've just introduced in a voluntary way tracking of upfront embodied emissions in building materials for both the Part 9 or the Part 3 buildings. So it's introduced as voluntary, but through these studies, we're looking at how we might move that forward and advance it as part of this framework over time to 2028. And this is where your input and your involvement, because you're really key stakeholders in making this happen, is very important. Next slide, please. So as we mentioned, there are the two studies going on. You'll be hearing about both of them just briefly today, an update on those. So we'll just move on. And what we're really looking for you today is any kind of input that you have that will inform our final deliverable on the Part 3 study. The Part 9 study has been released, but the Part 3 building study will be finished by July, and that's going to produce something called a policy primer to the City of Toronto. So it's going to be making recommendations to the city on how we manage this issue even better over time. So looking forward to your input. We may be changing the Toronto Green Standard requirements in 2023, also depending on those recommendations. We may include a target, for example, coming from this study. Okay, so just to give you that as some context. And now we'll pass it over to our first speaker, who is Ryan Zizzo from Mantle Developments.
Great, thanks so much, Lisa. So I'm just going to be giving an overview on what we mean when we're talking about embodied carbon or embodied emissions. As Lisa said, this is all about the upfront carbon associated with materials in construction. So this graphic does a good job of kind of explaining. You can see in the orange here, this represents the operational emissions, which we've been doing a good job of managing and reducing over the past number of decades through things like the Ontario Building Code, the Toronto Green Standard, the past 3 versions. All of those documents and policies have put caps on the amount of carbon that we can emit from our building on an annual basis through energy efficiency requirements. But everything else on this graph has been basically overlooked or not addressed in any meaningful way. And it's all these pieces in blue that we're talking about when we say the embodied emissions or the embodied carbon of our built environment. So this ranges from where the materials are processed from, where they're mined from or harvested from, any transportation that happens along the way, manufacturing processes, and even installation. So at the construction site, all of those, excavation trucks we're seeing, all of the diesel equipment associated with construction. We can move into the use phase and think about the material impacts of the use of the building. So things like replacing the roof, changing out the windows, replacing the doors, any major renovation that happens, and then even into the end of life, things like demolition, disassembly, landfill, anything associated with that. So clearly, all of those processes have carbon emissions associated with them, but none of them are currently included or managed when we're talking about energy efficiency requirements or even operational carbon requirements on building and annual operations. So to look at the global picture, the 2 colored pieces of this pie of global emissions show the total impact of buildings, which is almost 40% of global emissions are from our building stock. The red you can see is the building operations, that's just under 30%, but the blue is the construction processes and the materials that go into our building stock, and that's over 10% of global emissions. If we break that down a little further, cement and or concrete is responsible for nearly 8% of global emissions. So there's only 2 countries in the world with more than 8% of global emissions. That's China and the US. So if cement and concrete were a country, it would be the 3rd most emitting in the world. But the good news is there's a lot of easy things that we can do to reduce those numbers, a lot of low-hanging fruit, because these metrics haven't really been optimized until very recently. And that's what this study is all about. It's about not totally changing how manufacturers are working, but to find those easy wins and the low-hanging fruit to drive down this number and start managing these embodied emissions more actively. So I wanted to share this graphic from the World Green Building Council, which shows the individual life cycle stages of a piece of built environment. You can see, as you might see LCA reports, life cycle assessment is the process that we use to do these embodied carbon calculations, and that's short form to LCA. But when you see LCA reports, you might see or hear people report on these different letters like A1 to A5 or B1 to B5, C1 to C4. Each of those numbers and letters represent these different life cycle phases. So we call the A1 to A5 upfront carbon. So this is everything that happens before the building is occupied. And this is really where we're seeing the majority of emissions in the built environment. So sorry, I thought I had a different slide there, but and I like to show this graphic where this kind of shows why this is becoming such an important issue and why it's increasingly important on policymakers' agendas. The top part of the slide is how I like to represent how new construction, or the carbon footprint of new construction in the past. And this is just this graphic is showing the cumulative carbon in the atmosphere over at various years throughout a building's life cycle. So in year one, when the building hasn't been turned on yet or occupied yet, 100% of those emissions are from embodied. It's from constructing the building. And then every year we're getting more and more emissions from operating the building. And if we were to look at year 60, the end of life over the total life cycle of a building, this might be a typical split for buildings of the past, where their operating carbon is significantly overshadowing the embodied carbon. So when this was the case, it made sense to focus on operating carbon. That's what we've been doing for the past few decades. But this is really no longer the case for new construction. And there's two reasons for that. One is buildings are much more energy efficiency. New buildings, new construction is much more energy efficient than it used to be. So because of things like the Toronto Green Standard and the Ontario Building Code. And the second reason is our energy system is much lower carbon than it used to be. Things like coal phase out of our electricity grid, things like PV panels, solar panels being installed, wind turbines being installed throughout the province. All of those has made a unit of energy much lower carbon. So when we take both of those into account, buildings are using less energy and the energy is less carbon intensive. We're now at a situation closer to the bottom of the screen here, where operating carbon is not vastly overshadowing embodied. In fact, it's almost equal depending on the specifics of the project and other factors. But things get even more interesting when we look at shorter time frames. As anyone who's been following the news has seen, all of these dire reports from the UN and the International Panel on Climate Change, the IPCC, they're saying we have 10 years or less now of real time where we can make significant change and avoid the worst impacts of climate change. Unfortunately, the scientists are saying if we keep on our path as usual, within 10 years, we're going to have positive feedback loops kicking in, and we're going to really not really have the ability to limit the worst impacts anymore. So when we look at a smaller time frame, you can see here that the embodied carbon is actually the vast majority, the dominant source of these carbon emissions for new high construction buildings. And this is why it's so important to have embodied carbon on the policy agenda for new construction going forward. So that was an illustrative example. This is a real project in Ontario that we did an analysis on for the provincial government. This was results from a LEED certified government institutional building. This was actual operational numbers because it was already in operation for 2 years, and we kind of just extrapolated the first 2 years consumption over the course of the building. But when we compared it to the the embodied carbon in the blue, you can see it's the operations is not vastly dwarfing the embodied. They're equally bad. And when we look at the shorter time frames, it is the embodied that's dominating. I'll also point out this red dotted line here. This is just the concrete. So we can see almost 50% of our carbon emissions in this building was of the embodied carbon of the materials was just due to the concrete on this project. And I should say this project didn't try to actively reduce its embodied carbon. This was just a measurement. So there's, as I said, a lot of low-hanging fruit. We really can pull this down quite significantly by making a few key design changes, which my colleagues will talk about later in the presentation. So one of the key things to know about one of the first steps to address on this issue is that we want to start producing, manufacturers can be producing and providing something called an environmental product declaration, or an EPD. And I like to describe this as basically a nutritional label, but for construction materials. It's really a disclosure document. It helps show what the environmental impact of a product is, including all of its life cycle phases from extraction to manufacture. And some EPDs can also include future phases like use and end of life, but not all of them. So that's something where we need to have a little bit of understanding on how to interpret the EPDs. But basically, they help us understand the carbon impact and the environmental impact of the products. And this is one of the, what you might see in a typical EPD. You might see a table like this with the different life cycle phases, A1, A2, A3. As I mentioned earlier, that's extraction, transportation to the fabricator, and then the actual manufacturing process. And you might also see a whole list of different environmental impacts. But similar to nutritional labels, you kind of don't need to look at every single number and every single thing on the label. You're probably only going to be looking at a few key things on the document, such as maybe the serving size, which we call a declared unit in LCA world on EPDs. You can see on this example, this rebar, these results are being presented in a per metric ton. So 1 metric ton of rebar has this amount of impact. And we might be looking to optimize maybe 1 or 2 key metrics like fat or carbohydrates or something like that on a nutritional label. On EPDs, I would say let's focus on the global warming potential, or GWP, which is the term for the carbon impact, the embodied carbon in the product. Want to also say that there are different types of EPDs. We see many industry average EPDs where we look at the total impact across a nation or a region, for example. And the 2 EPDs at the top here are good examples of Canadian industry average EPDs. On the left, we have one for cement, and on the right, we have one for ready mixed concrete. So those were produced by looking at the typical impact for different users across, or different producers across the country, and then averaging it out based on total flows of these materials that we see manufactured across the country. But if I'm trying to calculate the carbon impact on one specific building on one of Lisa's City of Toronto projects, those industry average numbers aren't as great as I would love to see, because what I really want to know is the impact of the concrete that we're ordering on this project from the plant down the street. And these, if we're looking at industry average EPDs, they don't quite give us that data. So ideally, we'd like to see the industry move towards what we call facility specific EPDs, which means one specific manufacturing facility, the one down the street, hopefully, what is its carbon impact for its material it's making. And this EPD at the bottom here is an example of that. You can see it says right on it, Milton plant in Ontario. So this is for a lightweight block that was built at that one specific Milton plant. So we really want to see the industry use more EPDs, but ideally shift to the facility specific, plant specific EPDs. And I won't go through all this, but just to show you, there are a lot of embodied emissions policies already on the books across North America, and even more in Europe and elsewhere. In Toronto, as Lisa said, as of Sunday, any new building permits for City of Toronto owned buildings will need to calculate their embodied carbon and disclose that. Edmonton has also passed similar a requirement. The federal government has their own set of embodied carbon requirements that are coming into place. It needs to be disclosed from major structural materials this year. As of 2025, they're targeting a 30% reduction in embodied carbon in structural materials. And the City of Vancouver has a 40% reduction target that they're rolling out over the next few years. Also, Waterfront Toronto has its own specific requirements that require the reporting of embodied carbon. Just to quickly say, there's a whole list of states and federal initiatives in the US, a lot of this under the term Buy Clean. You might see that in some news articles. Buy Clean is all about procurement having lower carbon materials that they're purchasing. So anyone who's interested to learn more about these policies, I'd recommend you to reach out to me. I'd be happy to chat about any of these. But we're going to just keep moving on here because I want to save time for the other speakers in discussion. Just to say, I know that it's a big topic that we're talking about here, but there are some really great tools that can be used to help calculate these numbers for us. And on the screen, we have a bunch of them. Some of these are free to use, Canadian-based, and other ones are have different functionality and can work with BIM models, or some of them are automated with material processes. So there's a whole range of tools that we can use to help streamline this process. And I'm just going to quickly comment on the fact that we can do these assessments at multiple times throughout a building design. The idea isn't to do, one LCA at one point of the project and then it's done, because there's really different solutions that we can uncover if we do these assessments at different parts throughout the project. So again, we're going to share these slides probably next week, but won't go into all of this in detail. But just to say, at concept design, we can have a high level understanding of material type. So concrete versus steel versus mass timber, for example. At detailed design, we can really have a more finer grain idea of different layout decisions, or the number of partitions that we're using, and things like that we can optimize. If we were to use this at the procurement, tender, and construction phase, this is where we can really get into more specifics about the the specific material properties. So the amount of recycled content in a given material, or the location of a specific supplier. Again, ordering from down the street or shipping it in from China, right? Those are going to have very different carbon impacts. So these are the kinds of things we can discover throughout the different life cycle or throughout the different design phases. And then finally, we could even do an LCA post-construction at use or occupancy, which obviously we don't really have an opportunity to make changes anymore, but this is really the final number that we know, because as you all know, there's lots of change orders that happen during construction. So we can use this as our final number and have lessons learned for future projects going forward. Just very quickly to touch on some best practices in reducing embodied carbon. The first thing is just to ask suppliers. I guess you guys are the suppliers, but when I'm talking to owners and designers, I say, ask your suppliers, just say, is there a lower carbon option? Because a lot of you guys and girls do have lower carbon options, but the market needs to demand it. We also found that super tall buildings have a higher carbon impact. My colleagues will talk about that a little bit. And then some of the material specific requirements, things that some of you on this call are a bit well aware of, using Portland limestone cement, it has a 10% less carbon impact at the same cost and same performance as normal cement. Maximizing the SCMs in our concrete mixes. We see lots of mixes using 5-10% SCMs, but we can really go significantly higher than that, which comes with a lot of carbon reduction. And then even considering longer curing times, so not having a standard 28-day strength for concrete, but for key elements that don't require early strength, we can go to 56-day or even longer, and that can help us really reduce a lot of the carbon impacts of that product. For steel, we want to use North American steel, local steel, high recycled content. For wood, we want to make sure that it's certified, that it's from forests that are responsibly managed, not clear cut, that are being reforested. And then finally, at the construction site, there's things we can do like using electric vehicles wherever possible for transportation, for delivery, and even construction. We're starting to see more and more construction equipment that is electric. And it really makes no sense for us to be constructing in these very low emission grids and we're using diesel at a stationary location, right? We should be able to find a way to plug those equipment into our low emission grid and take advantage of that. And then finally, I'll just say that when we talk about LCA and these embodied carbon assessments, it's having a lot better, more complete picture of the carbon impact of our buildings, but a lot of them aren't every material. A lot of these assessments don't include every material in a building. They mostly focus on the structure and the envelope. So in the LEED green rating system, they actually provide this, what to include and what not to include in your life cycle assessment. And they say specifically, do not include electrical, mechanical, controls, plumbing, elevators, excavation, site work, parking lots. So there's a whole bunch of carbon that we're still ignoring when we're doing these assessments according to LEED. So we're trying to work with the industry to have clarity around that and maybe have a primary scope that is these, kind of easier to find materials of the structure and envelope, and maybe a additional scope, a secondary scope to be more inclusive and have all of the impacts of our buildings. So I'm going to hand it over to Kelly. We'll have a time for discussion later, but yeah, thanks all for being here.
Great, thank you, Ryan. I think I'm going to go through some of the findings we've had in our study, and I think some analysis of a few buildings here. So an overview of the TAF project. It's the first of its kind to collect and compare whole building life cycle assessments in the province of Ontario. We focused on the Part 3 buildings, Ryan and myself, that include obviously a kind of larger than 600 square meters and a range of types, commercial, industrial, multi-unit residentials. We've been working as a part of that with 2 of the city's own projects to understand potential implications of policy and also wanting to see where reductions could happen right now within a design phase, and mostly that happened in the specification of materials, which is very pertinent to today's group. The purpose of this is to be in the future green standards, as mentioned off the top, and to be beginning to educate and engage industry broader as we, the urgency of this that Ryan underlined. Next, please. So here are the findings. We got about 51 projects responded to our call for data, which is incredibly encouraging. It tells us that life cycle assessments are happening across the province and across types, as you can see here. So the mean say embodied carbon per square meter, you can see here in the red dots that fall below 500 in all types, and in some types there's quite a bit of range. In other words, the range is quite, the groupings are quite small, and some of that has to do with either a smaller sample size, but I think, within mixed use residential, for instance, that tight kind of tight distribution of the 80th and 20th percentiles is encouraging and telling us that we're kind of in and around an industry norm here. Next, please. The question of where, why production phase matters, and why, again, in the 8 years or less, we have to do dramatic changes here. You can see it's in this production phase. It's all up front. This is where our emissions related to buildings exist here. So it's how we harvest and process the materials we're using to build. And where they are in a building, as you can see, it's a large, so much of it has to do with, I think, how we found our buildings, the materials and systems that we use to do our superstructure, which you see in the beams and columns and floors. And then finally, the materials we use to clad our buildings, the windows and wall systems on the far right there, has a huge impact on the building. Part of this, when we looked at the city's own buildings, here's a representation of the EMS station, which was a very low per square meter building, and we wanted to identify where to make savings, and figured, look at the big items as the locations where savings could happen. So here, a representation of total emissions by part of the building's construction. Next, please. And through working with the architects and with the city's project managers and also the construction and costing team, we identified 6 or 7 key places to make specification adjustments very late in the design process. So switching out the type of insulation, looking at the specification for the concrete, looking at the type of sealant on the concrete floor on this project. And in doing so, we managed to shave out 800 tons of emissions off this project, and are now encouraged that the architects Diamond and Schmidt are looking to push similar assessments across all of their projects. Next, please. Underpinning some of this work, the research that I've been leading at the University of Toronto at the HAF Studio, and we've been looking at kind of further beyond the kind of number and where these numbers are in a project. So we've been working with architects and developers across the city. Last year, here's the 10 projects we looked at. As you can see, a range of scales in multi-unit residential, all either complete or in construction in the last 5 years. Next, please. And these are the results of those assessments. And you can see these are fed into the slide I showed earlier, but a pretty big swing between types. And we were interested in why that is. I mean, the low rise on 250 square meter versus the mid to high rise in around that 500 mark. And within even the typology, some pretty big discrepancies. Next, please. So the first thing was that carbon intensive structural systems are the largest driver of reform, and concrete, cast in place concrete, by and large, is the main source of emissions in the construction sector of Toronto right now. Probably no surprise to anybody. Low-rise projects that employed wood frame structures above concrete foundations had roughly half the embodied footprint of projects that utilize reinforced concrete for their whole structure, and that the lowest carbon mid-rise project had a hollow core structure, a steel on hollow core, that reduced the volume of that project. Next, please. And here's a representation of the material, the radius representative of total emissions, and then the pies telling you, where those emissions live. And as you see, concrete dominates the overall emissions profile, but right next to it is aluminum. Next, please. And that aluminum is really in our envelopes. I think that the way that we're currently building the walls of multi-unit residentials, certainly the mid and high-rise projects, they use a lot of aluminum, and they also utilize a lot of foams, and specifically XPS insulation historically. These two products and two material classes have extremely high global warming potential. XPS, in the case of the blowing agents associated with its making, though those have been banned and it's been reduced, it's still a highly emissive material. And aluminum, as you can imagine, we're sourcing it from all over the world. The smelting, the processing of it is incredibly energy intensive and results in a high embodied emissions. Next slide, please. And here you can see some of the envelopes of the projects that we looked at. So on the right are the window wall systems, kind of typical of Toronto mid and high rise projects, highly emissive and also low on a thermal performance perspective. And the ones towards the middle are ranges of say brick rain screens and steel studs in comparison. Next, please. Another driver from a planning side, and I think the kind of unintended consequences of our planning regime have been that foundation works, parking structures, and below grade floor area have disproportionate impacts on embodied carbon. And that for mid-rise and high-rise projects, up to 20 to 50% of a project's volume could be in the concrete below grade, then the basement. Next slide. So for even the low-rise projects here, you can see our propensity to go down into the ground in Canada here comes at a big cost. The one on the right to accommodate underground parking. Next. And here are a range of the emissions associated with mid and high rise projects, all largely driven by either subsurface geotechnics and or the parking requirements that satisfied the project. And just to say, there's really, it's all completely unregulated part of the planning regime as far as how deep you go, which is, I think, needs to be something to be reconsidered and eliminated. Next, please. Also, that the parking's dimensional impacts the structural grid of a project. So the spacing of a parking space is not the same of a kitchen or a living room. And when you stack these things on top of each other, they result in these really large transfer slabs. Next. And to illustrate that here, you can see the red grid of the housing and the black of the parking, resulting in the entire ground floor of this project being a cast concrete transfer slab to accommodate 2 floors of parking beneath. Next. So right now we're drafting the recommendations and a policy primer. As you can see from the beginning, we're at the 2nd of the 4th workshop here. And we'll be working with taking the feedback from these workshops and putting that into a primer document to then be lead to a final workshop with the recommendations of how to be incorporated into the next version of the green standards. Thank you.
And I'll just let everyone know that unfortunately Chris wasn't able to join us today, but we recorded his talk from last week, so we're just going to play that recording right now, and then we'll come back and continue the live session. We don't have the sound coming through, actually. I think you have to share the sound, please.
Sorry, Ryan, 1 second.
All right, thanks, Kelly, and thanks to everybody for tuning in today. My name is Chris Magwood. I'm with Builders for Climate Action and the Rocky Mountain Institute, and I was the lead researcher on the Part 9 study. We had a great team involved in this and a great partner in Passive Buildings Canada, and we were really excited to be able to undertake this study. Next slide, please, Ryan. So one of the things different between this Part 9 study and the Part 3 study is that we were provided with plan sets of homes in the GTHA from developers. So we were working from as-built homes, and so we were able to do the exact same analysis using the exact same tool on all of these plans. In total, we had 59 plan sets that represented, in the 2 years that the study was looking at, 503 as-built homes made to those plans. So it was a pretty, it was a good size of a sample. Gave us a really good sense that we were capturing lots from across the whole the GTHA, and that we would, the results would be very comparable within that data set. Okay, next. So just to, Ryan talked about scope and so did Kelly, but for this study, we used a tool called BEAM, which we developed in-house at Builders for Climate Action. And it's just giving us results for the what we call the material carbon emissions, that upfront part that that has to do with manufacturing the building materials. So we are not looking at transportation to site or installation. And again, we're sort of focused there because we know that that's where the big chunk of the emissions live. We're also looking at basically the structural enclosure and partition materials. So things that aren't included are things like site work, stairs, mechanical, electrical, and plumbing equipment, surface finishes, appliances, all of that kind of stuff is not included. So we figure, looking at some studies where all of those things are wrapped in, that we're kind of accounting for maybe 50 to 60% of all the embodied carbon in the houses we're looking at. But we focused on this range of materials for a couple reasons. One is it's the set of materials where we have the best data set. We can represent all of the materials in a really good way, whereas lots of the ones we left out, there just isn't very good data for them. And we also feel that these are the materials where a lot of action can be taken by somebody to reduce those emissions. You know, the only way you're going to reduce your mechanical and electrical and plumbing emissions is to plumb less or wire less, and that doesn't seem like a change that we would be driving with this study. But you can, you know, think about your structural materials, your insulation, your windows, you know, all of those things. Really big reductions can be achieved in those material sets. So we'll go to the next one. So this is kind of the plot for what the emissions across this whole study looked like. We looked at 3 different typologies: semi-detached, single-detached, and townhouses. And you can sort of see those first 3 boxes on the left. The single-detached houses in general had a higher carbon footprint because they're bigger and because the entire enclosure of the building is being attributed to that one residence. And you can see that semi-detached on the left is a little bit less overall, and the townhouse is less again. And so, you know, that's interesting from a planning perspective, that, you know, if we want to drive overall emissions down, thinking about grouping houses, that, you know, townhouses are a good way to go. But essentially, we're looking at just under 43 tons of emissions per house for the structural enclosure and partition materials. Okay. However, we didn't want to just use the lens of overall emissions because the size of the units matters. And so if we look at emissions per floor area, you can see that the results really tighten up. On the left, that's the total floor area. So that would be taking in garages and any unheated space in the house, so unfinished basement areas and things like that. And you can see that you know, suddenly the results really tighten up because we're attributing emissions to the size of the building. So obviously, if you make a tiny house, it can have a lot less emissions than a really big house just by the volume of materials. So by looking at it by floor area, you can see that actually these Part 9 buildings fall within a pretty tight range. We also looked at it by heated area. So this would be sort of wrapping the garage and any unheated basement space in, so that you're actually sort of paying a bit of an embodied carbon penalty for that. And then even further to the right is habitable area. So making sure that we're really only attributing emissions to the places where people live. And you can see at each of those phases, it goes up a little bit. But the interesting thing here is that, you know, we did find over such a large group of homes, a fairly tight range in which all of these landed, especially when we look at it per meter squared. Okay, next. So this just kind of sums that up for the heated floor area. So the carbon intensity ranged from a best case of 116 kilograms per square meter of heated floor area. The highest example in the study was 561 kilograms per square meter, and the average landed at just over 191 per square meter. So, you know, you can see that there's a pretty wide range there, but a lot of the buildings were clustered really closely around that average result. We were also able to look at the impact of different material categories, and very similar to what the Part 3 study found. we found that just 3 material categories, concrete, insulation, and cladding, accounted for 72% of the total material emissions. So, you know, if we're going to really try to make a difference here, these are the areas where we want to concentrate. You know, things like roofing, framing, post and beams, windows, all of that stuff. You know, there are certainly savings to be made there, but the lion's share belongs in just those 3 categories. And so that's where we would recommend that we kind of pay attention in the low-rise market, is to making reductions there. Okay, next. So also along the lines of the Part 3 study, we took a couple of the buildings from the study and looked at making some material changes. Same kind of parameters as with the other study. We wanted to look at you know, achievable, affordable, code compliant type substitutions that could be made. So we started with a building that had 81 tons of emissions, or 262 kilograms per square meter. And we did things like use a lower carbon concrete mix, then substituted cellulose insulation in place of the other insulations that had been used in that building. Took the XPS foam wrap around the building and substituted wood fiberboard, changed the brick cladding for engineered wood cladding, and took a bunch of the other categories like flooring and drywall and didn't change the material, but just changed to the best available product, the product with the lowest emissions in those categories. And you can see it's pretty remarkable that that brought about a 75% reduction in those emissions. So we went from 262 kilograms per square meter down to 66 with just a small handful of substitutions, all of which are doable and achievable today. And then if we go to the next one, this stood out to me as being really interesting. So this is an overlay on the graph you just saw. So you can see now we're looking at one of the houses that had the lowest carbon footprint to begin with. So that little orange box on the left, it started with only 33 tons of emissions associated with it. We applied all the same substitutions, and we ended up at 56.5 kilograms per square meter. And the previous house landed at 66 kilograms per square meter. And we saw this over and over when we made substitutions that in effect, it didn't have to do with the design of the home or the location of the home or the typology. If you sort of chose the best available materials, they all kind of, you could get all the houses into that sort of like 50 to 75 kilograms per square meter range. So really interesting to see just how much savings there is available to us in emissions in this low-rise sector.
Chris, sorry to interrupt, but one really important question came up in the chat that I think you'd want to address. They said a 75% reduction in carbon at what cost?
Yeah, that at no cost or very negligible cost. There in some cases the material we're substituting is actually cheaper than the one it was replacing. In fact, in a couple of the main categories, that's true. In this case, the lower carbon concrete doesn't have a cost penalty. Moving to cellulose insulation looked cheaper. The wood fiberboard is more expensive than the XPS. The engineered wood cladding was cheaper than the brick. And in the flooring and drywall categories, it was just a brand choice. So, negligible cost there. So I think we see that in general, you could achieve that suite of changes at or about the same cost. It might be a little more, it might be a little less, it might be on par, but there's really not a heavy price penalty to be paid here. And I think if you do this smartly, there could be no price penalty, and in fact, the house could be cheaper. Thanks for directing that one, Kelly. So I just wanted to show you, we have done some other studies for other regions. We did a study for NRCan, looking at model homes across the country. And we also did a study for the cities of Nelson and Castlegar in BC. And what's interesting is, we found that the ranges, especially in the sort of worst results and the average results, are pretty close across the country, which gives us a sense that, the results we're seeing in Toronto aren't necessarily unique, but that, kind of everything in average landed between sort of 150 to 190 kilograms per square meter. Okay, next. And this is where I was going to sort of bring up the cost issue, because one of the things that really stands out from both the Nelson study and this GTHA study is that, you know, none of the builders who submitted plans for these studies are building buildings to intentionally have a lower carbon footprint, right? They're just sending us the plans that they're currently building now. This fits their business model. It's what they build, it's what they sell, it's how they make their living. And it's interesting to see that, you know, there was a whole cluster of homes in the GTHA study that came in around that 116 to 120 kilograms per square meter. That builder was not intending to make a low carbon home, but they're beating the average by 40%, which means, you know, somebody's business as usual is already 40% less than the average. And, you know, when you compare that to some of the higher results, it's a huge achievement. So even if we can just get everybody to be doing the thing that this builder is already doing, that's a 40% reduction. We don't get easy 40% reductions in the climate change space very often, but this really points to that being possible. And the same thing happened in Nelson. You know, there's again, a builder just building the house that they always build, and beating the average by 50%. So, you know, it tells us that there's a lot of room, and that we don't have to sort of, initially anyway, go very far out of anybody's comfort zone to see, you know, 40 to 50% reductions in this building space. Okay, next one. And so this was, you know, I definitely invite you to go download both of these reports. There's a lot more in them than we're able to cover in these 10-minute sessions, but the final recommendations for the Part 9 study, we recommended that all new home designs do this kind of calculation at an early design phase, and that we sort of recommend that municipalities ask for that report in the permit phase. That everybody, you know, in this call, designers and builders, request EPDs from all the manufacturers. I noticed there was some notes in the chat saying, you know, are there enough EPDs, or I couldn't find product specific EPDs. And I think, you know, I've seen the number of EPDs really explode in the last couple of years. And that's because, you know, people are demanding them. And I think the more we demand them, the more complete data set we'll get, the better, you know, we'll be able to specify the products that meet our
one omelet, please.
Yep. Yep. Should I warm up for you?
Somebody is
yeah.
Ordering lunch, not on mute. So if you could mute, that would be great. Thanks. To explore these immediate potentials for material substitutions that I mentioned. And again, the report goes into a lot more depth than that, where we can easily see sort of a 20 to 50% reduction from business as usual in a really sort of simple and cost-effective way. The report also goes into looking at what materials could move us even further along that path. Some things that, you know, are kind of coming or not as common in this market, but are being used elsewhere, that can actually get us between 50 and 100% reductions. So, you know, start looking at that now, start thinking about that, start planning for that now. Our study didn't look at design options for achieving reductions, but as Kelly mentioned with the large building study, you know, if 35-ish% of the carbon footprint of all of these homes was in their basement, was in the concrete in the basement, you know, one simple strategy that we didn't explore here because we were using as-built plans, but, you know, thinking about the actual design of the building as a way to reduce the carbon footprint further. And then finally, you know, we would encourage residential builders to, you know, start declaring the carbon footprint of their homes and, you know, pushing to get really great results, and then using that. You know, surveys show again and again that, you know, 60 to 80% of Canadians are very concerned about the climate and want to make choices that are sort of climate smart and climate friendly. And I think offering homes that can show that they're, you know, 40, 50, 60% less carbon footprint than a competitor's is going to be a real advantage. So, you know, sort of making these results part of the discussion around building and buying homes.
Great. I guess I have to click through his slides. I really loved Chris's study and results, but I think my favorite part was the omelet order, definitely. So we're going to take a quick break now. Let's make it 7 minutes so that we can all come back at 1 o'clock, and then we will dive into our discussion. So we'll see you guys at 1 o'clock. Thanks. Okay, everyone, welcome back. So we're going to get into our discussion in just a few minutes, but we're going to start off with some thoughts from Adam Auer, the president and CEO of the Cement Association. So thanks a lot, Adam, for joining us. You can take it away.
Can you guys hear and see me?
Yes, we can.
Thanks. That was very sudden. I wasn't quite ready to click my mute and camera buttons there, but anyway, thanks very much, Ryan. Appreciate the opportunity just to say just a couple of minutes of comments. First, I just want to congratulate the City of Toronto for going down this path. This is, an area that the Cement and Concrete Association has been advocating for a number of years. We understand embodied carbon as an important component to the life cycle of not just buildings, infrastructure more broadly, and that cement and concrete in particular have an important role to play in addressing that challenge. On that point, we have globally a net zero roadmap out to 2050. We're just sort of putting the I's and crossing our T's on a Canadian version of that roadmap as we speak. So we hope to be able to share much more about what the different touch points are for our decarbonization journey, where we think we can get by 2030, 2040, and 2050. And I'll just say that procurement policies around embodied carbon are a really important part of what's going to help us get there. You'll see already sort of the beginnings of that commitment emerging from the industry side. Someone mentioned that there's been a real explosion of product disclosures through EPDs. And I think you've seen, and certainly in the cement and concrete world, that is very much the case. Most of our members have or will soon have facility-specific EPDs for cement. We will be publishing before the fall regional-specific industry average EPDs for ready-mix concrete, and precast will follow shortly thereafter. And I think that will also kind of harbor the beginning of more and more product specific EPDs from the concrete manufacturing side as well. And these are really things that are being done in preparation for procurement policies like what City of Toronto is proposing, but also at the federal level. So the federal procurement policy was mentioned briefly. Their requirement is going to be based around first and foremost disclosure, so a requirement for EPDs, but also project level benchmarks for embodied carbon, which are going to focus on concrete for starters, in part, I think, because we were the first industry to volunteer to do so. So I think, I hope that you see from our sector's perspective that, really trying to play a proactive and leadership role in this space. I'd just say a couple of things, maybe cautions is the right word, but things that we're sort of learning as we feel around our way around what a good embodied carbon or low carbon procurement policy looks like. And the first and foremost thing for us is to stay away from prescriptive solutions and focus more on really unlocking the innovations that manufacturers can offer in this space by really focusing on performance as the primary driver for specifications in our space. I can give you, an example. We've seen some jurisdictions in the US, for example, take the approach of prescribing maximum cement contents in concrete, and by doing so, really cutting themselves off from some of the other types of innovations that can actually get deeper embodied carbon reductions from concrete. The second I would say is to appreciate the role of material efficiency as well. I know Chris Magwood's presentation talked, for example, about how they didn't really get into design-based efficiencies as an opportunity, but in our own analysis, we think that is actually a really significant part of the decarbonization process, is just by being smarter and more materially efficient in the way that we use materials like concrete. It requires a different way of thinking about design and certainly a more sophisticated understanding of the procurement process and how you incentivize reductions through the whole sort of procurement decision-making chain. But it's a huge, we think for concrete alone that might be, up to a fifth of our 20% total reduction potential just by looking at material efficiency in the built environment. The third I would say is, think about, especially for the developers, you got to think about incentives to do business differently. Obviously, disclosure is a big part of it. Obviously, creating embodied carbon benchmarks is a big part of it. But if you really want to get at, again, the sort of all the different levers through the decision-making value chain, thinking about how you can incentivize those decisions, which are clearly not incentivized at all right now, is going to be a really important consideration. And then just two more points and I'll stop. One is around the fact that we are seeing such a proliferation of interest in embodied carbon policies right now. We hope that as different models, procurement models are developed, that there will be some kind of a consolidation, because of course you can imagine that if there are, you think about all the different municipalities and provincial projects and private sector actors and federal projects, it would be very helpful not to have to navigate a whole diversity of very different kind of approaches. And we hope that with time and as people learn from each other and other jurisdictions, that we'll see some consolidation around best practice, just to make it a bit easier for, material manufacturers, but others in the construction industry as well, to navigate these processes. And the last thing I would say, and this is a conversation that we're quite happy with the federal government direction, is, at the moment, the whole area of life cycle analysis, the methodologies, the assumptions, the levels of disclosure, we still have a lot of learning to do here, and in particular when it comes to the sort of thorny question for material manufacturers around material substitutions. We think there's really good evidence out there that we haven't quite got the right metrics yet, in particular for really tricky things to measure, like biogenic carbon associated with natural materials. And so the federal government approach to that has been to really focus on material specific requirements. So looking to really reduce the embodied carbon from concrete. They're going to move to wood, they're going to move to steel, aluminum, glass, and make sure that within each of those material streams, we're providing the right signals and incentives to get reductions. And as we evolve, as the life cycle sort of methodologies evolve, and as the data gets better, we'll be in a better position to make smarter decisions where material substitution makes sense. But I just felt like, we need to at least flag that there are still a number of uncertainties and assumptions there that need to be worked out before we can be confident in those types of comparisons. And I think that's really all I wanted to. Oh, one last thing on that last point, just so that you guys, in case you didn't see it, the federal government has an initiative called Low Carbon Assets Through Life Cycle Assessment, where they're really trying to create centers of excellence around life cycle data and methodology. And we've got agreements with them to provide much more granular data about our sector than they've had in the past. And they're working on the same for other manufacturing sectors. But they also received almost $200 million in the last budget to do research in the LCA space to really up the sophistication of the types of analyses that we can do, including like whole asset lifecycle assessments and material comparisons and all that kind of stuff. So if you're not plugged into that project and this is an area that you really want to get geeky about, then keep your eyes on NRC, because they're going to be doing some really interesting work in this space. Thanks again for the opportunity, Ryan. Really appreciate it.
Great, thanks a lot for all those comments, Adam. That was really great. So yeah, I think we can probably wrap up now. I think this was a really great conversation, and we've been taking notes. As I said, we won't be sharing the discussion that was had here, but we will be kind of refining or I guess pulling out some of the key points to help inform the policy primer. And we will be having a final wrap up webinar in July with that final policy primer. So we would invite all of you to attend, and we will share a link to the today's presentation part of the day that we'll send around to you also, that you can share that with your networks as well, so you can get this conversation accelerating in all of your networks. So I'll say thank you one last time, and maybe I'll just hand it over to Lisa for a final word.
Oops, there we go. Yeah, great. That was very helpful for me. You know, even with the level of discussion that we had, it was helpful for me to understand kind of where you're coming from and, you know, what some of the top issues would be for you. And I hope that you're able to reach out to us if you have any other thoughts. Anyone else who was on the call, you know, questions, concerns, or comments are always helpful in kind of finalizing where we go next. So thanks so much for coming today and sharing your opinions.